What if I told you that the James Webb Space Telescope has just recorded something that shouldn't exist? I'm not talking about a distant galaxy or a monstrous black hole. I'm talking about something much closer and, at the same time, infinitely more unsettling: 3I Atlas. What Webb revealed about this cosmic visitor is turning everything we thought we knew about comets upside down. The first true infrared image showed a composition so bizarre that it left scientists speechless. Carbon dioxide levels 8 times higher than those of water vapor. 8 times! No one can explain how that's possible within the cometary physics we know, or by any established natural process. Webb's infrared spectrograph has just mapped an interstellar comet carrying the chemical signature of another star system, an object older than our solar system itself, perhaps older than most of the stars visible in the sky. It all happened on August 6, 2025. When the James Webb team received the raw data, they immediately realized they were looking at something extraordinary. Every pixel of those images whispered stories of places we will never see, tales of a cosmic traveler that crossed the abyss between the stars to visit our solar neighborhood. This wasn't just another pretty picture of a celestial body. It was the first true portrait of 3I Atlas, an interstellar comet that had traveled inconceivable distances to bring us frozen fragments from another time, from another sun. The story of its discovery began weeks earlier, in early July 2025, when the Atlas monitoring system detected something moving against the fixed background of stars. Its trajectory made no sense. The bright point soon drew attention because it was only the third confirmed interstellar object to pass through the solar system. Before it, we had found only 2 such visitors: the mysterious Oumuamua, with its inexplicable acceleration and improbable shape, and Comet Borisov, which, although more normal, still carried chemical and structural enigmas. 3I Atlas, however, seemed even more unusual, and its path would bring it close enough to be observed by the most advanced instruments humanity has ever built. A race against time began, as astronomers knew the object would soon vanish forever into the depths of interstellar space. Atlas was traveling at an absurd speed, over 200,000 kilometers per hour, on a hyperbolic trajectory that would take it past the sun only once. Unlike ordinary comets, which follow elliptical orbits and return in predictable cycles, this was a true outsider, a messenger from the regions where stars are born, destined never to return. The capture made by the James Webb Space Telescope was a triumph of engineering and almost unimaginable precision. The technical challenge was enormous. Stationed at the L2 Lagrange point, the telescope had to track a tiny, fast-moving, almost invisible target against a shifting star field. Every trajectory correction had to be perfect, like threading a needle in the dark from millions of kilometers away. And yet, they succeeded. The NIRSpec spectrograph locked on to the comet and recorded not just an image, but a complete map of its spectral composition. And that's when reality began to bend before the unknown. The measurements revealed a bright coma dominated by carbon dioxide, not water vapor as expected. The CO2 intensity was 8 times higher than that of water, a value unprecedented in any comet ever studied. This forced scientists to rethink everything about the formation and evolution of these icy bodies. In our solar system, solar heat usually causes water ice to sublimate, forming the bright tails we know so well. But 3I Atlas seemed to resist this process. Its water ice remained nearly inert, hidden beneath a crust that may have insulated it thermally. The gases being released, carbon dioxide and carbon monoxide, evaporate at much lower temperatures, suggesting that they are the main drivers of its activity. This chemical signature acts like a birth portrait, a fingerprint of its original system. All evidence indicates it formed in a very different environment from the one that gave rise to the Sun, perhaps near the carbon dioxide snow line in another protoplanetary disk, where temperature and pressure shaped a radically different chemistry. But the surprises didn't end there. Webb and other observatories detected light and polarization properties never seen before. Measurements revealed a deep negative polarization that abruptly reversed, an almost non-existent behavior among known comets and asteroids. This suggested that the dust grains in its coma had an anomalous structure, perhaps porous or rough-surfaced, interacting with light in unique ways. These findings placed Atlas in a category of its own, a new class of interstellar visitor. Even more shocking, despite its intense degassing, 3I Atlas showed no detectable non-gravitational acceleration. In other words, its gas jets, which would normally alter its trajectory slightly, had no measurable effect. This could indicate extraordinary density or extreme structural rigidity. Preliminary estimates suggest a mass exceeding 30 billion tons. If true, it would be one of the most massive comets ever observed, explaining its apparent immovability. And then comes the most disturbing point of all, its age. Models suggest that 3I Atlas could be between 3 and 11 billion years old, potentially older than the solar system itself, which is about 4.6 billion years old. Analyses also revealed metallic nickel in its coma, extremely rare, implying formation in a high-energy environment, perhaps near regions of intense heat and collisions. This mix of metals and volatile gases creates a chemical profile utterly unique among known comets. Think about that. An object that has spent billions of years wandering through interstellar space, traveling at inconceivable speeds, enduring cosmic ray bombardment, micro-impacts, and stellar radiation fields, and yet still preserving ice, molecules, and fragile compounds. 3I Atlas is literally a time capsule, preserving within it the chemistry of a young galaxy. For eons, while stars were born and died, it drifted through the void, surviving conditions that would destroy any ordinary body. It may have passed through dense molecular clouds, absorbing new material or undergoing surface chemical reactions. Some of the organic compounds observed may be the result of these interactions, blending traces of its origin with scars from its long journey. Unlike the comets of our solar system, which have lost many volatiles after repeated solar passes, Atlas retains an almost pristine composition, a chemical snapshot of a stellar system that no longer exists. Observations from the Swift and New Horizons telescopes detected faint water signals, corresponding to a sublimation rate of about 40 kilograms per second when the comet was more than 3 astronomical units from the Sun. This confirms the presence of water ice in its nucleus, but in much smaller proportion than carbon dioxide. Curiously, about 20% of its surface already appeared active at that distance, highly unusual. Large icy grains may have been releasing vapor far from the surface, like tiny mobile fountains in space. The Hubble Space Telescope also joined the observation campaign, imaging the comet in July 2025, more than 400 million kilometers from Earth. The images showed an elongated, teardrop-shaped coma and helped scientists understand the dust distribution and tail behavior. Meanwhile, ground-based telescopes like Gemini North and South tracked changes in brightness and coma structure. It became a truly global operation, observatories across the world and in space coordinating efforts to study a visitor we may never see again. The comet is expected to reach perihelion, its closest point to the Sun, at the end of October 2025, and astronomers expect it to grow even more active, revealing new compounds and perhaps changing its appearance entirely. The problem is that during this critical phase, Atlas will pass behind the Sun from Earth's perspective, becoming invisible to our instruments for several weeks, a frustrating gap, precisely when the most dramatic transformations should occur. That's why Webb's data are now priceless. They serve as a baseline for what will change after perihelion.
And what if 3I Atlas fragments? What if it releases gases we've never seen in comets before? Whatever happens, future observations will help us understand not just this visitor, but perhaps the chemical history of the galaxy itself. This comet, possibly 10 or 11 billion years old, has crossed the void for unimaginable ages to finally pass through our path. It carries within it the echoes of stars long gone, frozen fragments of protoplanetary disks that dispersed before the Sun was even born. Every measurement, every spectrum, every data point collected by James Webb adds another layer to the mystery. Carbon dioxide 8 times higher than water, metallic nickel in the coma, no detectable non-gravitational acceleration, extreme negative polarization, and an age that predates our own stellar home. Perhaps when Atlas re-emerges from behind the Sun in December, we'll find natural explanations for all of this. Physical processes not yet fully understood, but still possible within known laws. Or perhaps we'll find signs that the universe is even stranger than we imagine, and that some objects carry secrets from times and places our science cannot yet decipher. 3I Atlas, with its impossible composition and endless journey, teaches us humility. It reminds us that the cosmos is vast, ancient, and filled with phenomena that challenge our understanding. These interstellar messengers are not just exotic versions of comets we already know. They are witnesses of other worlds, other eras. They are silent fragments of a cosmic story that stretches far beyond our own origins. And now, thanks to James Webb, we have the privilege of observing them up close, of reading, in their gases and dust, the words written by stars that died billions of years ago. The universe, after all, is far stranger and far more beautiful than we ever dared imagine. And 3I Atlas is living proof of that.